Morning.
How do you do, sir?
Good. What about you?
Yeah, it's a bit of a slow start to the day, but yeah, we're getting it figured out. Had a bit of um, a dishwasher mishap last night, so things are
Ah,
in disarray.
and the kitchen was flooded.
Yeah, not too bad, not too bad. We found the leak, cleaned it up, ordered the part, so it'll be here probably tomorrow.
Mhm.
In the meanwhile, we
Okay,
got a dishwasher in the middle of our kitchen.
that
That's,
happens.
that's what you do. This is the technology that was created in order to make our lives easier, and on average, it does.
In general, it does, but
Hmm.
if it fails, okay. If you could find the problem, then
Hmm.
it's okay.
Yeah, yeah.
Because
Problem was pretty
because this
obvious. It was the part that was dripping.
ah, because they are quite amazing. They are quite simple machines,
Uh-huh.
and not so simple at all. Um,
Yeah,
but
and
okay.
all of the engineering has already been done and packaged up, and it's just okay. You unscrew this and unplug that, and put it in the new
Mm,
one. So,
yeah, but more and more they are not made to be repaired anymore.
mm, yeah, that's true. Yeah, this one's pretty old, so yeah, pretty easy to repair as long as you can still get the parts.
Are the ones that still dry everything well. If you put in
Oh yeah,
plastic things,
yeah.
the new ones they don't dry at all.
Hmm.
Uh, I read about your hackathon ID.
Yeah, yeah. I was thinking, you know, how much? Well, we have kind of a 4 hour overlap between the two of us of good working hours. So how much could we accomplish in 4 hours? And
Hmm.
I would like to find out. So
I think it's a very good idea.
yeah, yeah. So we'll plan to to set aside a time. Probably it's looking like it's going to be the weekend after the 27th. So yeah, what I was trying to say,
Yeah.
very poorly, was
Mm.
that I'm available the week before the 27th and the week after. Um,
Ah,
so
okay.
yeah, so yeah, the weekend before
Well,
is next weekend. That's a little bit
mm,
too early to get this set up, but then
so wait, so that should be the 3rd of August,
yeah, that sounds right.
Saturday. Okay. Oh, then I will block that one. Um, let's block it for the moment because otherwise it becomes more difficult.
Yeah.
So if you want to change, just let me know. But for the moment, I blocked the 3rd of August then. So then we
Sounds
can
good. So yeah, we
whatever
can get
time.
started around this time. We'll record. We won't do this live, but we'll record,
Mm,
and then I can edit it down into something that would be watchable, so that people don't have to sit there and watch for 4 hours. And yeah, let's see if Jinaga lives up to the promise of solving all of the mundane problems for
mm,
you, and just letting you focus on building your app.
mm. I hope it will. Because I'm always getting more on
Mm-hmm.
behind. But that would be the moment to see where we are for a real test case.
Yeah. Yeah.
Because in meanwhile, you released the new the
I
final
did.
release
Yes.
or the
Yes.
first release.
Yep. Yep. Version 1.0 of Jinaga.net
Mm,
is launched. Um, and yeah, so I had a backlog of things that I wanted to accomplish before calling it 1.0, and then as I'm working through those things, other things kind of pop up, and it's like, you know what, that it really should it really should do that, because that's plumbing through a lot of the system. Get
mm,
that done before we call it 1.0. Um, and so yeah, I got through that backlog, and then there were still a few things on there that I was like, you know what, this is not really 1.0 worthy. For example, the optimization of the feed endpoint. So right now we call feed, and then we get back some fact references, and then we call load in order to fetch that data. And the idea is that you don't load the things that are already in your local database. But as it turns out, kind of working through what happens in practice, it would actually be less bandwidth and less latency to go ahead and fetch those facts directly from feed. And then, if you've already got them, then you drop them. But
Get everything anyway.
yeah, and it really comes down to the size of a reference. So this was something that the team at Improving was really focusing on when working on the client application. There is they were looking at the payloads as they were coming back, and it's like these references are these huge strings. They're base64 encoded SHA-512 hashes. So 88 characters long. So so those were really big references, and then the things that they were protecting were really small bundles of data, really small facts. And so the first optimization that we found was that when you got back the facts, then in load, they would refer to their predecessors by reference, by hash. So these really long strings were repeated inside of that JSON structure in order to build the graph. And it's like, okay, this is all one structure, and you can compute the hash on the receiving side. It's going to be the same as on the client side, on the sending side. So let's just replace those hashes with indexes within the graph. It's like, okay, that shrunk that down. And then with respect to the feed, we came up with the idea of rather than the index starting over with each graph, why doesn't the index start at the beginning of the feed, at least as far as that same client and that same server, that conversation is concerned. So introduce the idea of not just a bookmark, but a session, and you can start a session over, but still continue with a bookmark later in the stream, and then it would give you those indexes within the feed within that stream. So you could even refer back to facts that aren't in this particular payload because the sender already knows that the recipient has received them by this ID. So now combining those two ideas, we should be able to include the facts within the feed rather than the long references, and have a much smaller feed payload. Plus, you also have the benefit of having the facts immediately, so you don't have to make that separate call. So it reduces the latency.
Okay, so you don't do a load anymore after a feed?
Right.
Well, the feed gives the facts straight away.
Yeah.
Okay.
Yeah, and that's the optimization that I have planned. I decided that was not enough to hold up the 1.0 release, because that optimization would be kind of behind the scenes. There's already a protocol negotiation that I built into that API. So I'm going to have to start talking about protocol negotiation versus API versioning. It's so much better. It solves the problem. It's already built into HTTP. That's the way HTTP works. But API versioning is the programmer trying to take over protocol negotiation and doing it badly. So, I should just talk about protocol negotiation. Why you should do this instead.
And protocol negotiation is what's the difference between the two? Because then the client and the server are saying, I'm supporting this version, and you take the best version that both support.
Yeah. So
But
the
what's the difference with versioning then?
Yeah. So the difference with versioning is that you'll typically um, label an API as version one, version two, version three.
Mm,
Um, to be quite honest, I've only seen it ever go from version one to version two, and that was a really big, uh, big chore for this particular client. Um, Most of the time, people just stick on version one, even though the API is changing. But then the way that you talk about the API, the way that you exchange that version number, there's several different options you can choose. You can put it as part of the path. You can put it in a
mm,
header. Um, there was a third option. What was the third option? Yeah, actually, I think content type was the third option, but you would just put um, the version number inside of the content type. So that's getting closer to content negotiation. Um, But the big problem with that kind of API versioning is that um, it's it's all or nothing. So this is version two of my API, and um, so if you're making small incremental changes and you just change one endpoint or you just change one, add a new property to a JSON object that you return from one of those endpoints, then uh, do you call it version 2? I mean, there's a lot of friction against doing that. So people say, nah, I'm not going to call it version 2. We'll just tolerate extra fields that we don't know about, and and also tolerate missing fields. We'll code that in, and therefore we don't need to change the version number. And so you end up making lots of incremental changes, and then at what point does it switch from version 1 to version 2? And when it switches, how much has changed? And this one client where I've actually seen it done, it was because it was a complete rewrite of the API. They may as well just called it a completely different endpoint, but they wanted to reuse the names. They wanted the same
mm,
mental model. It was still the same domain, so it made sense to have the same resource names, the same type names, but they were just completely redesigned. Um, so yeah, they called it version 2, and so then version 1 and version 2 had to live side by side on the server for a long time. Um, and and then there was the problem of that was just the version at the boundary, at the controller, but then the code underneath was evolving. So you had this version 1 API that was calling into this now newer code,
mm.
and it was a constant translation layer. So it was a big chore just to get version 2 up and running, far bigger than it would have been to just write a brand new API. Um, so yeah.
And then where does protocol negotiation comes in?
Yeah. So with protocol negotiation, you can make that determination on a case by case basis. You're not versioning the whole API. Um, so so the way that it works in HTTP is the accept header says I will accept these particular types, and then the content type of the return says, well,
Mm,
this is the one that I'm actually giving you. Um, and so each individual call, um, each request um, has that negotiation. Now that negotiation only satisfies the get. You can't do the same kind of negotiation for post or put. Anything where the client comes up with the content is like the client's making the first call, so how can it negotiate what the protocol should be? So so instead for that you do a pre-flight check using options, and you say, okay, for this resource, options, this resource, these are the data types that I, as the client, could send you, and then the server responds and says, okay, these are the data types that this endpoint accepts. So okay, uh, actually, I think that first part. It's been a while since I implemented this. I think that first part is not true. It's just the client asks the question, hey, what are the options? And then the server says, these are the data types. And so it says, okay, I'm going to pick that one, and then I'll use that as my content type when I post. Um, so, and then of course the client can cache that because it's talking to that same server and over and over again. So it doesn't need to redo that pre-flight. Um, so that that gives you a way to negotiate on a case-by-case basis, um, and so rather than just the generic um, application slash JSON, you can use a content type that is X dash, then your company name, then slash your resource type dash some version number, and do that same kind of negotiation. And now for that one call, you were talking about that version.
It means that for every different resource, you can have a different negotiation.
Right, exactly. So it can evolve a lot more smoothly from one to the next, and there's a lot less friction to changing the version number. So so then what you could do is you could take the shape of the data structure. Say you've described that data structure in C#, so you've got a C# type. If you can then run that type through a function that puts it in canonical form and computes a hash, now you can automatically come up with a version number that changes every time you change the shape of the structure.
Yeah, but what is the advantage then of having that version number in that case?
Yeah. The advantage of using the hash is that it takes the work out of the hands of the developer. The developer doesn't have to remember to change the version number. Every time the structure changes, that hash changes. One thing that you might call a disadvantage is that it's not incrementing, but actually I don't see that as a disadvantage because nobody really cares which one is newer than the other. They're just two different structures.
Because having that version number, that hash, might allow you to continue without renegotiating. The first time you negotiate all the settings for all the resources, and then you say, okay, for version number 58, for example, these are the negotiations. And so next time the client logs on and say, I'm version 58, the server knows automatically what are the settings that correspond to that version number.
Yeah. So there you're putting that version number 58 over all of the resources.
Yeah.
So if you change just one, then now you've got version 59, and it's everything the same except for this one.
No, but in that case, it becomes, it was 58, it becomes perhaps version 1 or version 377, because they are not sequential. It's a hash.
Okay, with the hash, then it jumps all over the place, and that doesn't upset anybody because they're just like, well, that's the one that I want to use, and it's supported, or I support this set, you support that set. The idea of caching that across all the resources, though, that does mean that you are constraining, you're forcing yourself to come up with a new hash every time you change any of the resources. So it could be that you've got a C# description of your entire API. Maybe you take you're using Swashbuckle, and so you compute your swagger.json, and then you hash that. So anytime you change your API at all, then it computes a new API version number. That's going to change a lot more frequently than if you do it per request. If you make a change to just one endpoint, then the others could still, if they were just talking about their own data structures, could still use the same hash, the same version, but because of that one change, if it's a version that you cache across all of them, then it's going to change more quickly. I suppose that I can't really come up with a good argument against that. It seems that if you're doing content negotiation uh, on the request, then you're already within the context of the request. If instead you are using the path, maybe you put that version number, that big hash in the path. So it's v3 3f7 and and then somebody makes a small change, and now it's a very different version number. Yeah, that seems a little bit more on the extreme side than per request, but it could be made to work.
Yeah, let's see where it gets us, because that means that you can, at a certain moment, you say, okay, for that small feature, I don't support, for example, level 1, level 2 anymore. I only support the latest version, whatever that latest version is. And the rest of the API still supports previous possibilities. Is that the purpose?
Yeah. Well, yeah. I should rewind this and say that content negotiation worked really well for Jinaga because Jinaga is application agnostic. So what we're talking about here is when you're making a change to an application, you're changing the structure of the endpoints. And so application changes happen fast, but protocol changes, application agnostic protocol changes, happen more slowly. So it might not be fair to say, hey, this worked for Jinaga, therefore you should use it in your applications, because it is solving two different problems. Yeah, so but even though that might not be fair, I'll do that. I'll continue to do that anyway. And so the idea is that if you the goal is to make sure that if the client is sending a certain JSON object, the server is expecting exactly that shape, nothing more, nothing less. Typically, we will allow the client to send slightly more, slightly less, because as the application changes, you're adding fields, or sometimes you're removing fields, but mostly you're adding fields. And so, if it's typically the server that's ahead of the client, so the server would be expecting more fields than the client can send. So as you add a feature, you start to make those fields optional. And so the server has to have some extra logic on it to say, well, if this one's not sent, then I make this assumption. And so the alternative of having this content negotiation is the client is telling you explicitly, I'm sending you this version of this data structure. And so the server can have those different versions as different C# classes and say, okay, that's the version you're sending me, so I'm going to deserialize this JSON into that particular structure, and now things don't have to be optional anymore, and I don't have to make assumptions. So then it's a matter of how do you choose to communicate that, and I think content negotiation is a good option.
Okay. We'll see how it works out in practice.
Yeah,
because I don't really feel I don't see the consequences of it for the moment.
Yeah, and what I usually recommend, and so I don't know if I'm changing my recommendation right now. That's interesting. What I usually recommend is something called that I call structural versioning. So the structure itself tells you the version, which is kind of similar to that hash idea, except the way that I implement it in practice is that rather than just anything goes, here's a JSON object, there's a specific way to organize your JSON object for your for your initial request or your response, and that is that at the top level you've got names for second level objects, and the presence or absence of those objects is the structure. So yeah, for example, if we were talking about let's go back to the Festify example. So we're talking about I want to purchase tickets for a show. So so I'm going to send you a request. This is my purchase, and then it's going to have a show object, and then that show object is going to have the show ID and all that kind of thing. And then I'm going to have a payment object, and that's going to have all of the payment information in it. I'm not just going to put show ID and payment information at the top level. I'll have them at the second level. But that way, if I need to add another feature, so let's say that in addition to buying the tickets for the show, I also want to pre-purchase parking. So now I've added that feature, and so a client that knows about that feature would send show and payment and parking. It would send those 3 top-level properties, and each one of those would be a separate object. And a client that doesn't know about it, an old client, is still just sending the 2. So now the server just checks to see, does this object exist? Is there a parking object? And then if so, everything in that parking object is required. There are no optional fields. So that kind of straddles the line there. You're still doing things manually by checking for the existence of a property, but you're doing that within some constraints, following a pattern, and that helps keep things explicit.
Okay.
So that's structural versioning.
Now, if that can help versioning, make it easier to change your data structure, that would be very helpful.
Yeah, and yeah, the advice that I usually see, let's do some API versioning. Okay, let's go ahead and find a place in our API to stick the v1, and that's how we get started. Knowing that now we've got that place, we can change it to v2 at some point in the future. But you're still, unless you change it to v2 as soon as you add another endpoint, you're still, kind of, sloshing around inside of all of this conditional logic with the optional properties, and until you feel enough pain to say, okay, now it's time to take on v2, and then you've got a whole other set of pain. Versus, here, okay, let's start with the pattern of every object is 2 levels. So, I'm going to tell you about an act. Well, here's a JSON object with 1 property, act, and then all the information about the act. Wait, why didn't I just put all that at the top level? I'm telling you about the act. Well, because the pattern says it's always 2 levels. But that is where you put in that room for future versions. And now that is at a smaller granularity. That is per object, per request, which means that there's a lot less friction to changing the version for that one request, because it's not going to affect any other requests or any other types.
Completely on its own.
Yeah.
Okay. And that's already in the new version, or that was something that will come later?
Oh, okay. So yeah, this is all just advice for how to design a JSON API. So when you look at my Pluralsight course for building distributed systems, I talk about structural versioning in there. Yeah, this is just something that I bring up whenever the conversation is like, hey, we need to plan this version. All right, this is what we'll do. And people say, that's a weird way to do it. It's got some advantages. Think about it. Seems to be a common theme. But yeah, as it pertains to Jinaga, there currently is some support for structural versioning, and there is more support coming. So this is probably a good time to switch to some screen share so we can talk about that. Okay. And besides that, I haven't actually had a chance to share on the stream all of the lovely things that have been happening. So we should hit on that first. All right. So first lovely thing that's been happening. The Jinaga Replicator as a service is available in Azure. So I am currently in Azure. I'm looking at a particular resource group called Jinaga Test, and have no resources in it. So I want to go ahead and create a resource. Takes me to the marketplace, and when I'm in the marketplace, I can search for Jinaga, and I see Jinaga Replicator. Hey, I can use AI to search. Cool. So, Jinaga Replicator. We have quick explanation of what it does. Offline storage for mobile apps and PWAs, conflict detection and resolution, real-time collaboration, model-based security rules, and shows you a little bit about what it's going to be, what it's going to look like in order to use that replicator. So you can set up your authentication with Apple. You can set up your authentication with Google. We'll have other screenshots up here as well. And then if we take a look at the pricing and plans, we've got two plans. So the first is development and testing. So that has a 1 month free trial, and it's $20 a month for a small number of users, small number of facts per day, but that is intended for you to build your app, to put it out on test flight, and get a few people trying it out. Production, you can get one that's got a lot more users, 10,000 users, 1 million facts per day, and that is $100 a month. So compare that to what it costs to run a Postgres database and just build your own backend. You're going to be spending about $300 a month in order to build it yourself. So, or even to take the open source Jinaga and just deploy it to the cloud, you'll end up spending $300 a month. So I want you to have a lower cost option that's easier to set up. So that's what that's about. So I'll subscribe to the dev and test. Oh no. Yeah, it timed out on me. Let's see, what was I using? I think I was using me. Yeah, me at mycompare.net. Yeah, here we go. Oh my. Okay. Azure's having some difficulty. Let me go back to the portal. Me at mycompare.net. Go back to Jinaga Test. And let's try this one more time. Okay, development and testing. Subscribe. You gonna work? Wow. That is really interesting. So I'm going to try real fast a different login. Let's go to Michael at qedcode.com. Now this is the one that I use for actually running the replicator as a service. So all of those resources were related to running it. But this is a test resource group. Let's see if we can create a replicator here. subscribe to dev and test. That is really fascinating. So far this is all Azure. Nothing has actually hit the Jinaga Replicator. So I am curious. Let me go back to me at michaelperry.net. If I were to, I do have a subscription. It is this one, Jinaga Test. If I were to create a Postgres database, so we've got Azure database for Postgres. So that's got, just that one plan. So take a look at the pricing. Oh, this doesn't actually have the pricing in it. Somewhere in here it's got okay, there we go. There's this, you have to select a few properties in order to get the pricing. So, yep. $260 a month for the standard compute, and then another $14 a month for storage. And then you've got the high availability option, just only slightly more expensive. So why wouldn't you choose it? But yeah, that's still more expensive than setting up just using the Jinaga Replicator. Let's see. Oh, wait a minute. I might have this. Oh, yeah. For what I've got selected, it's $550 a month, so you're adding high availability. Oh, wow. Okay, that's why you would be careful about choosing that. Yeah, so this is for development. We don't need geo-redundant. Yeah. Okay, so just for development, $16 a month. Yeah, but then, as soon as you go to production, if it's general purpose. Wow. Yeah, this is even more expensive than I remembered it being. Anyway, I'm not certain why Azure is doing the OSNAP thing, but that was one thing that I wanted to demonstrate. Is like, hey, it's there in the Azure Marketplace. Okay, and in typical fashion, things are breaking on the stream. Let's do just one more try, just to see if it was a temporary thing. I'll do development and testing from here. That's probably not going to make a difference. Yeah, it doesn't. Yeah. Okay, this is just general information about that. Okay. But then, number one, available in the marketplace if you can manage to buy it. Number two, version 1.0 is out, and so we've got additional documentation around that. So we've got installing the packages. I think we did talk about this briefly on the last stream. Talked about Jinaga Maui is there, but now it's version 1.0. And we've got where we can define our settings. I don't know if we talked about this on the stream, but I think we might have talked about this pattern.
We have had that previously.
Okay.
I don't know whether we saw it last time. Last time we concentrated on the builder class.
Yes.
But not on the settings.
Yeah. So this is a pattern for each developer to have their own settings, so they can each set up their own private replicator. Mm-hmm. And then you can also have your production settings. So since none of these things are secret, because it all gets packaged up and shipped with the application and it can all be decompiled, then it's not quite so bad to have your production settings in source control. That way, your CI/CD can copy those production settings into the source code and then do the build, and then it's all packaged up. So this is one option. If you want to go with app settings JSON files, James Montemagno has recommendations on how to get that working. And then configure Jinaga. So these are the different things you can set up with Jinaga Client Create. So set up your logging, set up your HTTP endpoints, set up authentication. So you grab your HTTP authentication provider, which is now packaged into Jinaga Maui. So you put these authentication settings into that provider, and then it's able to use the web in order to authenticate with Apple or with Google. And in fact, you can provide additional providers if once the replicator as a service has ways to set those up. So more will be coming at some point. And then, then here, this is how you would log in or log out. And now it just tells you, is logged in, true or false? Was that successful in logging them in? If so, navigate to that area. When you log out, navigate to the not logged in area. And then, if you want local storage, then switch from Jinaga client.create to Jinaga SQLite client.create and give it a SQLite path. And everything else is the same. So, the authorization and distribution rules are defined elsewhere, so I just provided links to those. And then we get back into the defining a model, which we've gone through in great detail. Then here, control the view model lifetime. This is what we talked about from the outside last time. So now it is documented here. So in addition to observable objects, and iQuery attributable, you can implement iLifecycle managed, and that is from Jinaga Maui, and that gives you load and unload. And you just do your Jinaga client.watch to create your observer, and then you stop your observer. Then set up your navigation tree, which we described a bit last time. So here's your root. So then you've got two tabs, tab A and tab B. Tab A leads to some stack navigation with this child view model. Tab B leads to a different stack of navigation. And so then it can continue down from there. And then you use onAppearing and onNavigated from in order to declare viewed models to be visible or hidden. And then it figures out when to call load and unload. So this should be a nice complete set of documentation for how to get your application started. So, okay, wanted to take a little bit of time
So
to
the documentation is up to date now with the release of version 1.
Yes, it is. Yeah, and in fact, here, modeling, setting up your notebook. Oh, wait a minute.
Yeah.
I did change that. Interesting. Okay, I might have forgotten to accept a PR. These numbers should say 1.0 now. Okay, I'll shake my CI/CD server and get those 1.0s to fall out. Yeah. Excellent. All right. So, we were talking about structural versioning. So, let me come back here into Blog Maui and see if we can talk a little bit about what's available with structural versioning and where where it's going to go. So let's suppose that we have a, let's go back to the site list view model. So here we talked a little bit about site list view model. Why is that? Let's see, Jinaga Maui not referenced. It should be in here. There's Jinaga Maui, right? Well, let's just bring everything up to date with 1.0, just to... I thought that I already had everything updated to 1.0. That worked. Why is Jinaga Maui not updating to 1.0? Alright, latest stable, update, restoring. Okay. There we go. So, yeah, Jinaga Maui. It's referenced. Okay. Alright, well, at least the squiggles have gone away, so let's take a look.
Should be okay.
Yeah. Oh, all but one. Let's see. Yeah, that's... Yeah, we'll get back to that later. Okay. So, site list view model. We've got... we're using our user provider to add a handler. So whenever the user logs in, and this view model is visible, it calls this method. And then when the view model goes away or the user logs out, then it calls this method. So that keeps track of the currently logged in user and make sure that the query, whatever the view model is showing, is consistent with who's actually logged in. Without this user provider, I was sometimes getting a query that was for a user that had already logged out, and now I can't run those queries anymore. The distribution rules failed, and bad things happen. So now it's like, oh, okay, nope. And okay, on that note, let's suppose that you've got a user logged in and you're looking at this page, and then you navigate over. We will talk about the Maui program right here. You navigate over from this site list view model to the account view model in order to to log out. You can see those are on different parts of the tree. So because they're on different tabs. So if you hit the account tab, the site list is still in memory, because you can hit the tab and you should be right back where you started with whatever selection, whatever scroll position. Everything should be consistent. And so you're here, you log out, and now this site list view model is still in memory, but it has stopped the observer and cleared the sites. Now, if they were to hit that tab, then they would see this empty page. It wouldn't make a whole lot of sense. So what you really want is for it to just pop everything off the stack. This really became a problem when we were looking at something deeper in the stack, like this post view model. So let's talk about that scenario. So we are here in the post view model, and now instead of being based on the user, this is based on some query attributes. So we're looking at the post attribute, and so the watch starts from that post. So if this one's on the stack and it's still loaded, when the user logs out, since we're not using the user provider, this post data is still loaded. It's still in that view model. So the user logs out, you hit the other tab, and now you're looking at a post for a site that belongs to a user that's no longer there. Even worse, it could be that you come here, you log out, you log in as a different user, and then you switch back to this tab. And now you're seeing a post that's owned by a completely different user. You're not supposed to be able to see that. So, um, bad, bad user experience. Um, it's all on one device, but still that device needs to honor the fact that you've logged out, somebody else is logged in. So what do you want to do? So what I want to happen is when the user logs out, it pops the stack. All of this stuff comes back off the stack, and then you're forced to start over. Since this one at the top level uses the user provider, then that data is cleared, and the new user's data is loaded. So it's fine for that one to remain on the stack, but these two definitely need to get popped off. And so to accomplish that, there's the app shell view model, and yeah, here when you log out, there's now a method on the navigation lifecycle manager called unload invisible. So this is going to be specifically, since you're on that page, that's the only one that's visible, it's specifically going to unload anything that is not currently visible. So it's like, yeah, I know that the navigation might take me back there, but if it does, get rid of this stuff. None of this stuff should be visible. And so that, in addition to the guessing thing that happens every time a view model becomes visible and doesn't, that says, okay, no more guessing. These things should be unloaded. And now the user can't see data that was loaded while another user was logged in. It got unloaded when they logged out. So you know what? I don't think I actually have documented unload invisible. I'll need to make sure that I add that. Where should that be? Yeah, not authorization rules. Maybe, yeah, load user data talks about the user provider. This is really a navigation thing, so. Oh, wait, you know what? Configure, define a model.
Control view model lifetime.
Yeah, that's it.
Mm-hmm.
Yeah, so this is where I need to add that bit of information. Yeah.
Put it on the back and mention it like important.
Mm-hmm. Yes, very important. Yeah, this is one of those things that Jinaga is doing all of the right things on the back end. So it's running your distribution rules in order to make sure that you can't load data that belongs to a different user. But when you get to the client, if data has been downloaded to that client, then it's accessible. It's there in the in that local database. It's there in memory. So you typically don't log out of an application on your phone and pass it to somebody else, but there's a different level of expectation. So if you ever do get into a situation where you've logged out, you passed your phone to somebody else, and then they swipe and they say, oh, your data's still here. They can't actually do anything with it, but they can still see it. The distribution rules would have prevented them from pulling this data, but since it was already loaded, then it's there. So yeah, this is a collaboration between Jinaga and the application developer. Application developer does need to do a little bit extra work in order to make sure that the user gets a secure experience, even though Jinaga it does quite a lot of work to give you that security by default in the back.
But the moment that you log out from the application, then the data is not accessible. It's still in the SQLite database.
Right. Yes, that's true.
And in theory, somebody on the phone could have access to the database. But the moment that you log out from your phone as a user, then the database will not, at least on Android, the database should not be accessible to another user.
Yes, and that's true in iOS as well. If you log out of your phone, so at the operating system level. So here we're just talking about at the application level. The application doesn't know who the operating system user is, and so it's not controlling things to that degree. If there were that handshake between the application and the operating system, then basically you would have a different file system. You would have, therefore, a different database altogether. So when you logged in, your data is in your database. Log out on the phone, the operating system encrypts that file system, doesn't give this new user access to it, and now you're looking at a completely different database. Their data is not even here. So yeah, that would be another option. I would be interested in doing a bit of research to see what would that integration look like. How could I support that that style of application? Most applications that you download go through this extra login process. So hey, go ahead and log in. You can use your Apple ID on your iPhone, but you don't have to. You could use a different ID. Apple just says ours has to be first if it's on an iPhone. Google doesn't say that, strangely enough. So you could actually just ship all your apps with Apple first and not even do the detection. But it's probably best to put the native one first on the list. But then the user gets to choose. Do I want to use Apple? Do I want to use Google? Do I want to set up an email? Do I want to use my Microsoft ID? Do I want to log in using X, Facebook, whatever? But yeah, if the operating system and the application, so the built-in applications, know about the logged-in operating system user. So is that capability offered to application developers? I don't know. I'm sure it is. That would be another option that I could give application developers. So if you use that, then you can use this negotiation to log in as Apple or log in as Google for the replicator, but the operating system is protecting the local database. Yeah.
So you would say the fact that you log into your telephone is enough to log into the replicator?
Yes. Yeah. I think that would be possible. It's already that using the iPhone, if you hit login with Apple, it doesn't take you to the login page, but instead it gives you the on-device experience. So if you've got it set up to log in with facial recognition, then it says, okay, look at the phone, and double tap or whatever to accept this login, and then you're in. So yeah, Apple already intercepts that web request and turns it into an on-device request, and then it continues as normal for the backend. So Replicator as a service doesn't actually know that you used your face in order to log in. It's just Apple gave Replicator a token and said, okay, here's the Apple user, and it continued on its merry way and said, all right, you're a replication user. Yeah. So yeah, I think that would be another option. But then, of course, you could not even choose your identity. Once you start your application, you are logged in as the operating system user.
Yeah, but that would make it easier for users.
Yeah, I think so.
Mm.
And it would mean that this would no longer be a necessary part to give the proper experience of not seeing somebody else's data.
Yeah.
Okay. Well, we actually did hit time, but I did want to talk real quick about the structural versioning that is currently possible. So in BlogMao, we've got different areas. Inside of the blog area, we've got posts and sites, and we've got our model. So let's go into the model, and let's say that here I'm talking about sites. So who is the creator? What time was that site created? That way, the site deleted, site restored, the name and the domain are all successors of the site. So you can add new features to a site by adding adding more facts. That's what you usually do in order to grow a model. But if you needed to actually change the fields of the model, then you've got an option to do that. So let's suppose that in fact, it's so common that you can just add new facts to the model in order to evolve things that it's hard for me to just come up on the fly with a case in which you can't do that. So I'll really just talk about what the feature does. So if at some point you decide that you're going to have a string identifier. So in addition to the date time created, I'll pass in that string. So now I've just changed the model, so any sites that were created without that string identifier would not match this structure. So when I load one of those past sites, this identifier is going to be the empty string, because I said this is a non-nullable string, so therefore let me give you the default value for that. You're going to get back an empty string here. Which means you can't really tell, was this fact created with an empty string identifier, or was it because this is an old fact? So you might choose to make you might choose something different. You might choose to say, okay, let's make it nullable, in which case you'll get back null rather than an empty string, and maybe you have more confidence that you wouldn't have created a site with a null identifier. Now you're going back to that, make something null in order to evolve the schema. It's an option. It's not required. So now you can check to see, all right, did I get back a null? Therefore, this must have been an old one. I'll have old behavior, or I'll take an appropriate default. Or it's not null. Okay, this was a new identifier. I'll have the new behavior. So you've got that for adding fields. As you're doing this, you don't need to deploy any changes to the replicator. You might need to change authorization distribution rules as you change your model. Just adding a string wouldn't require you to do that, so this kind of thing would not be a change even to those rules. Then, what if you wanted to replace created at with an identifier? So it's like, in the past I had that, but now I want this. Or maybe it's even stronger. You want a GUID identifier. So no more of these timestamps. We have users that are creating several different sites all at the same time. We just want these are the GUIDs. Now they've got all the sites. So now you've got two different structures that you need to honor. So in the old ones you had created at, in the new ones you had identifier, um, and uh, and so there's no way to load an old one into this new structure, nor is there a way to load this new one into the old structure. It just doesn't go either direction. So the thing that does not currently work, but will work. I don't know if I should say soon, but at some point in the future, is you could name this with created at, and then go back to date time created at. So now it's the same fact type, but two different structures. And so Jinaga will use structural versioning here. It will say, okay, this one was saved with these two fields, therefore I'm going to use this one. This one was saved with these two fields, therefore I'm going to use this one. So now you have the issue of when I'm running a query and I'm getting back all of my sites. Some of them are this C# type, some of them are that C# type. How do I get them into the same list? Well, then you have an interface that you as an application developer get to set up. So control dot, and let's go ahead and generate that interface. Boom. And now you can have a list of iSite coming back, and it could be either one of these two. And so, yeah, now you can say, I'm interested in the creator. So they both have creator, so they both implement that. Cool. Now you can access it just from the interface. Or you can say, you know what, I'm interested in the identifier. Well, that one doesn't implement it, so now in here I can say identifier, not new good, that would be lying, but why is empty read-only instance has all zeros? Why is it non-invocable? Oh, yeah, there we go. So now you have decided what the default behavior should be, and you can put additional behaviors on these things because they're just records and they can implement interfaces. So notice I deliberately did not say V2 or V1.
So that's possible as long as the model is evolving. The problem remains if you really have a structure that changes completely, then you are still in trouble, I think.
Yes, yeah. So there are 3 levels of versioning. Level 1, you're just adding new facts. Level 2, you're changing the structure of existing facts using structural versioning. Level 3, you're just redefining your model. That level 3, that's where now the relationship between facts changes. Maybe something that was a successor becomes a predecessor. Maybe maybe you modeled it this way and then you realized, okay, I just need to go a completely different direction. So for level 3, what I recommend is that you change the fact types. Maybe you even change the root. So if you really want to, maybe you call it blog v2. I'm not not a fan of that for all the reasons that we just discussed. But you have some semantic meaning for this is the next version. We can talk about this this version and its capabilities and the marketing around it. So the branding for that new version, use that branding here. Um, and then you've got these two models that live side by side inside of your application. And now you've got this problem of moving from one model to the other. So within that that third style of versioning, you have two different options. Option one is that the client runs both queries. So it looks at the old structure and it looks at the new structure. It projects those both into a common data structure. So maybe it's not an interface that they implement, but instead you go even one step further and you map this projection onto a C# type, and so you can map a different projection onto that same C# type, and now you've got, these are two projections into this one common set of types, and then you can union them together, and those types are closer to what you see on the screen. They're almost view model types. They might actually be view model types. Yeah, so you union those together and show those. Like for example, here the post header view model. You might have the post header view model just has a title on it. It's pretty straightforward, but you might imagine this is a little bit more complex. This is what the user is actually seeing inside of that list. But if some of these posts were an older version, some were a newer version, take those two projections, turn them both into post header view models, then you union those lists. So that's one way of getting two different models to work together. Another way is to just completely move to the new model, but then have a background process that maps from one model to the next. So it sets up a queue of work to be done. So I'm looking for posts in version 1 that don't have a subsequent post in version 2, and then creating that post in version 2. And so you have that running in the background, and so as people are using version 1, it's feeding that into version 2, and so you bring up your version 2 application and all your data is there. So that's the furthest extreme of how you can do versioning.
That cleans up the old model, in fact.
Yeah. Yep. And if you have that background processing running at a seam within your infrastructure, then you can even clean up your old infrastructure once everybody's moved over. And no old facts have made it into the new infrastructure. So you use distribution rules to prevent that from flowing in that direction. That's, distribution rules are not just for security. They can also be used to partition your infrastructure.
Yeah. Well, let's see where we need it. Which method will be used in the applications.
Yep. And you don't have to choose right at the beginning which method you're ultimately going to use. Mm-hmm. So you don't have to save a space for that V1. You just start modeling, and you know that you've got these options available to you.
Well, I think if you just make a small change, you go with just the same fact, and if it is really a new model that you create, well, then you have to transfer your model in the background process. But, you can just decide the moment that you are in front of that bridge, mm-hmm. and see, okay, how are we gonna cross this bridge?
Yep. Much easier to make a decision once you have enough information. Making a decision before you even get to the point where you need that, I think you might have made the wrong decision for what you need now.
No, but I'm happy that this functionality is already built in, because we will definitely need it one day or another.
Yep. And like I said, the two different structures using the same, the same type, and choosing the structure based on the fields. That part's not built yet, but by the time we need it, I'll build it. And if somebody races out ahead of me and says, "Oh, I need that now," well, then I'll stop everything I'm doing and I'll help them get that working. But I don't see that happening. Yeah, still adoption is kind of poking at it as a wait and see kind of thing. So
Mm.
uh,
Yeah, but with the new book, with the release of version 1 now, it could
and with the
could get
replicator as a service on Azure, yeah,
yeah. Um, at a certain moment, everything comes together, and people will start using it.
yep, yep, that is
All
the plan.
right. So next week you will be there.
Yes, yes. Next week I'll be there, even though I won't be here for the weekend. But then,
Mm.
yeah, the week after that, we can do our regular stream and then uh, do the
Mm.
hackathon.
Okay, and then we can see how to prepare for that one.
Yeah,
Um, because then we'll start the model from scratch.
yeah. I think the diagrams that we already went through,
Mm.
those are good diagrams. So we can start with those diagrams, um, then model in notebooks, and then see how much of application we can start to build.
Mm.
So I'm confident that we can get through the notebook models in the first, certainly the first half, probably the first hour. Um, we can get through those notebook models. Yeah, yeah, this stuff is really fun.
Yeah,
And it
that's
goes really fast.
really fast because it's you.
Yeah, yeah,
With me, everything is going too slow, too
and
slow.
there might be something else to announce. There might be an additional helper. So if you don't have me, you might have a
Mm.
surrogate.
Artificial intelligence.
Maybe. Let's see.
as,
Let's see if I can get
as
this thing working.
Michael as a co-pilot.
Yep. Yep.
Okay, great. Okay, Michael, thank you very much. Then see you next week.
See you then. Thank you, sir.
Okay, bye bye.
Bye.